Alright, here we have a pretty standard connected objects problem. Our goal is to find the tension in the string between the two objects. Now, we've got one 8 kilogram object on a 40-degree slope and one 5 kilogram object on a 20-degree slope. And they're both slopes have a coefficient of kinetic friction of 0.1. Now, there's one thing we have to know starting out with this kind of connected object problem, that the acceleration of each object is going to be the same. So I'm going to call this A and this B. Okay? So for all points and purposes, we can also treat it as a total acceleration of both of them. All right? Now, we also need to know that the acceleration of A times the mass of A is going to equal F net A, which is going to be equal to 3 forces. Okay? 3 forces are F gravity, okay, plus friction of A, so F gravity, F friction of A, plus tension. Same thing with B. Alright, so let's get started. Now, we also know that F net on both of them together is going to be equal to F net on A plus F net B. Now, it just so happens that because the two tensions are going to cancel each other out, they always do. So we get FGA, force of friction A, plus FGB, force of friction B. Okay, now before we continue solving, we actually have to clear something up here. We have to know which direction the friction of these forces are going to go. So we know that FGA is down this way, and FGB is this way. Now, we also know which one's going to be stronger. Just from knowing steeper slope, heavier object, we know that A is going to be stronger. Which means that the whole connected object is going to be sliding this way, to the left. Which means the frictional force which opposes motion is going to be to the right. So we can actually rewrite this FGA minus FFA minus FGB minus force of friction B. Because all of the three of those are going to be opposing that strongest force. Alright, now let's put it together. We have FGA is 8 times 9.8 times sine of 40 minus 8 times 9.8 times cosine of 40 times 0.1 minus 5 times 9.8 times sine of 20 minus 5 times 9.8 times cosine of 20 times 0.1. All that should come out to be 23. Which then gives us A equals 23 over 13, which is the mass, an acceleration of 1.77. We can then plug that into these two equations here. And we get 1.77 times 8 is equal to force of gravity A minus force of friction A minus the tension. Why is it minus tension? Well, gravity is pulling this way, pulling the object this way. Friction is going to oppose that. We also then know that the tension is pulling backwards on that object, so tension is going to be negative. Alright? We already know these two values because we solved for them up here. And we should come out to get that tension is 30.2. Now, we don't actually need to solve the second one. But assuming that we did, we could go forward and say that 77 times 5 equals Fg equals tension minus FgB minus friction B. And both those negative, tension is the only one that's pulling to the left. Remember, this object is also going to the left. So left is going to be our positive, tension is positive, gravity and the force of friction are both negative. And again, we should get up that tension equals 30.3, which is simply just some sort of rounding issue somewhere along there. But it should be the same, and that's what we get. And that is a connected objects problem.